Is it modular? Are these things easy to deploy, or are power leaders in the data center space going to be ripping their hair out? What do you think?
Yeah, I mean, I think that's one of the most beautiful things that the leadership team at Micatu designed, is the modularity and the elegant complexity of this situation, right? So they've designed a sensor platform that, if anyone in the power industry knows what a hot stick is, it's a stick that you can put things on the power lines while it's hot, right, where you're in power. So our sensors can be deployed hot. You don't have to take an outage, right, as long as you use the right form factor, which is incredible because a lot of the sensing technologies out there require full outages, right? It is an intense construction situation to put in some of this equipment where we're saying, no. Give me a couple of hours and alignment, and I can get you fully connected, right? I can get you all of this data. And when you say accuracy, that's a huge point, right? So we're bringing in 0.5% on both voltage and current, which is solid data, right? That's going to get you to the point where you can do massive analytics, understand your power quality fully. But what's really interesting is the harmonics, because traditional instrument transformers or line post sensors actually act as passive filters. So they're going to be pulling out a lot of that harmonic data. So it's getting gobbled up like Pac-Man before you ever get a chance to see it, right? So what we're doing is we don't do any of that, and we're able to measure it and provide it. So on the voltage side, we actually go out to the 250th harmonic, which, wow, as an electrical engineer, kind of blows my mind. Because, yeah, I mean, it's like, what's out there, right? We just don't know. Again, we don't know what we don't know. And we've seen, some of this harmonic distortion start to creep up into these really high levels. And it's not something that's been studied super thoroughly yet, right? Because we haven't seen it in practice yet. And on the current side, we go to the 11th. We'll probably double that relatively soon. Current harmonics are more difficult to capture. But in any case, on both sides of the fence, whether it be voltage or current, understanding the distortion that's happening in that power signal is really important, and being able to capture that in an easy way, right? To be able to make a phone call, say, hey, can I get a set of sensors and a crew and be done in a couple hours? Mm-hmm. That's something we've never seen before. And it's something that we're really excited about at Micatu because we're able to provide this solution in a really, to your point, easy way, and then be able to integrate into existing software systems, right? So if you've got some kind of an energy management system, on the utility side, it might be an ADMS. We use DNP3, which is a very standard protocol. And we're able to send that data back and just seamlessly blend into all the other data points you already have, right? And then the data experts can come in and say, how do we correlate all this and make it really meaningful and actionable?